Hello everyone. I'm Tarun from CSE studying in Sri Venkateswara College of Engineering, and I'm here to give a presentation about various microprocessors and microcontrollers used in computing with specifications and applications. In this slide, we will discuss about what are microprocessors and microcontrollers. Microprocessors and microcontrollers are electronic components that are used in many devices which we use every day, such as phones, computers, and cars. Microprocessors are general-purpose CPUs that perform arithmetic and logical operations on data, while microcontrollers have a CPU, memory, input-output ports, and are designed for specific applications such as controlling a motor in a washing machine, etc. In this slide, we will discuss about the specifications of microcontrollers and microprocessors in a tabular form. First, when we come to the specifications of microcontroller, the CPU frequency of microcontroller is 8-bit to 32-bit. Whereas for microprocessor, it is 32-bit to 64-bit. And when we come to RAM, it is 1 KB to 256 KB. And for microprocessor, it is 2 MB to 256 MB. Flash memory 1 KB to 2 MB. And when we come to microprocessor, it is 2 MB to 16 MB. And applications of microprocessor are PC, servers, gaming, smartphones, gaming computers, and smartphones, etc. For microcontrollers, the applications are automotive, IoT, robotics, consumer electronics, IoT is Internet of Things, etc. In this slide, we will discuss about the applications of microprocessor in computing and electronics. Microprocessors and microcontrollers play a crucial role in the operation of electronic devices. Microprocessors are used in high performance devices such as PC and gaming consoles. Many medical devices like an insulin pump are typically controlled by a microprocessor. Automobiles, trains, and planes also use microprocessor technology. Microprocessor is also very useful in the field of instrumentation. Function generators, frequency counters, frequency synthesizers, spectrum analysis, and many other instruments are available. When microprocessors are used as a controller, the use of microprocessor in entertainment, equipment, toys, and home entertaining applications is making them more useful and full of features. In this slide, we will discuss about types of microprocessors such as CISC, RISC, and many more. CISC, complex instruction set computing microprocessors. These microprocessors can execute complex instructions with fewer instructions. And when we come to RISC, it is reduced instruction set computing microprocessor uses a simpler instruction set and can offer high performance. And other types are DSP, EPIC, VL, IW, each with unique architecture and applications. In this slide, we will compare popular microprocessors such as Intel x86, ARM, AMD, and many more which is present in the market. First, when we come to Intel x86, it's a popular microprocessor line for PCs with CISC architecture and superior processing power and speed. And ARM processors used in mobile devices, IoT devices, and embedded systems. ARM processors boost lower power consumption and high efficiency. AMD Ryzen, an advanced AMD Ryzen is an advanced microprocessor which has multi-core technology and it improves performance and it is mainly used for content creation. In this slide, we'll discuss about the factors which we should consider when we are choosing a processor for a project. The first one is power consumption. Choose a microprocessor with low power consumption for IoT devices and portable devices. And the second one is processing power. If your application requires demanding processing capabilities, select a powerful microprocessors. Cost. Consider the cost of the microprocessor when designing a project and compare different options to find the best fit. And the next one is development tools. In development tools, choose a microprocessor with extensive tools and resources available for easy development and debugging. In this slide, we will discuss about the applications of microcontrollers in computing and electronics. Microcontrollers are used in low power devices such as IoT and robotics. They are also used in automotive and consumer electronics. Microcontrollers, along with other technology, enable us to be able to detect disease with a human body before it's too late. Some common applications of microprocessor includes data processing, control system, and real-time embedded system, which is the common applications of microcontrollers too. Microcontrollers are used in medical instruments such as ECG machine, AcuCheck, etc. And when it comes to communication, it is used in cell phones, telephones, such answering machine, etc. When it comes to office equipment such as fax, printers, also contains microcontrollers in it. And when we go to the multimedia applications, it is used in MP3 player, PDS, etc. And in automobile, it is used in speedometer, which is present in the bike and cars, auto braking systems, etc. In this slide, we'll discuss about different types of microcontrollers, which are 8-bit microcontrollers, 16-bit microcontrollers, and 32-bit microcontrollers. 8-bit microcontrollers, these are the workhorses of the microcontroller world with a simple architecture that makes them easy to program and use. They are great for low power applications, but their limited processing power and memory can make them a poor choice for complex projects. When we come to the 16-bit microcontrollers, they are little more power, and 16-bit microcontrollers are a good choice. They offer more processing power and memory than their 8-bit cousins, but still maintain a relatively simple architecture that's easy to work with. They are great for applications that require more processing power, but they may not be able to handle the most demanding projects. And when we come to the 32-bit microcontrollers, for the most demanding projects, 32-bit microcontrollers are the way to go. They offer the most processing power and memory of any microcontroller type, making them ideal for applications like high-performance gaming systems, robotics, and IoT devices. However, their increased complexity can make them more difficult to program and use. When choosing a microcontroller, it's important to consider specific application and its requirement. Do you need an ultra-low power consumption, lightning-fast processing speed, a simple, easy to use architecture? Whatever you need, you select a microcontroller which is required for you when you're demanding, when you're creating a project. In this slide, we'll discuss about the basic difference between microprocessor and microcontroller. The first one is architecture. Microprocessors have a CPU and focus on processing data, while microcontrollers have a CPU, memory, and input-output ports and focus on controlling devices. When we come to the functionality, microprocessors are suitable for general purpose applications, while microcontrollers are best for specific applications. Cost. As microcontrollers are compact and have all the required components, they are less expensive. And when we come to the memory, microprocessors have limited memory while microcontrollers have larger memory capacity. And when we come to the power, microprocessors consume more power than microcontroller as they need to process more data. In this slide, we'll discuss about the future of microprocessors and microcontrollers, their advancement and trends. Artificial intelligence. Microprocessors and microcontrollers will play a critical role in powering AI and machine learning applications. Edge computing. With the growth of IoT devices, microcontrollers will be widely used in edge computing, enabling data processing at the edge of networks. Security. There will be an increasing focus on the security. In this slide, we'll compare an architecture of microprocessor and microcontroller. While both microcontrollers and microprocessors have a CPU, the former has additional components such as memory, input-output ports, and analog to digital converters. Microcontroller architecture is optimized for reducing power and low-cost applications, while microprocessor architecture focuses on processing speed and power for high-performance computing applications. Microprocessors are based on one human model whereas microcontrollers are based on Harvard architecture. And thank you for coming throughout this presentation. And I hope you have learned something about microprocessor and microcontroller. We hope you have found the information informative and useful. Thank you.